Here again, we'll use the first derivative test to determine extreme values for the function and also where it is increasing and decreasing. First, we need critical points. Those are endpoints of the interval, which here are 0 and pi. And also we need points where the first derivative f prime equals 0 or does not exist. So the derivative of sine of 2x is cosine of 2x times 2. We need to know where that's 0. It's nowhere undefined. Of course, cosine is a function for any number of x. So we'd simply divide both sides by 2 and care where the cosine of 2x equals 0. Now think about that. This argument here, 2x, or sum of theta, will give us a value for cosine to be 0. And cosine is 0, it's the x value of the unit circle. So cosine is 0 here at pi over 2, and also down here at 3 pi over 2. So we have some options. Pi over 2, 3 pi over 2, 5 pi over 2, those kind of numbers. But it's not just theta as the argument. The argument is actually 2x. So if we were to divide both sides by x, 2x equals pi over 2, or 3 pi over 2, just for example, and divide both sides by 2, or multiply both sides by 1/2, we get values or solutions for x. Just plain old x is pi over 4, which pi over 2 times 1/2, and 3 pi over 4. You'll see that both of those points are on this interval, so they're valid critical points. Use the critical points and the endpoints to cut up the interval. So this function goes from 0 to pi. There's one critical point at pi over 4, and another critical point at 3 pi over 4. We'll use the first derivative to test for behavior. The first derivative f prime is 2 times the cosine of 2x. Let me scroll down a little. And let's test some values. So if we choose f prime to be pi over 6, d of pi over 6, that's between 0 and pi over 4, we have 2 cosines of twice pi over 6. Cosine of twice pi over 6 is the cosine of pi over 3. And that value is positive, namely positive half. That means that this function is increasing on that interval. Then let's choose a value between pi over 4 and 3 pi over 4. A great place to do that would be pi over 2. The first derivative at pi over 2 is twice the cosine value at 2 times pi over 2. That's twice cosine of pi, which is negative 2. That means the function is now decreasing. And then we'll take the first derivative and test it between 3 pi over 4 and pi. We'll have to try 5 pi over 6. The only thing that's closer to pi than 3 pi over 4, so twice the cosine of twice 5 pi over 6 is 2 cosines. 5 pi over 6 times 2 is 5 pi over 3. So I need to multiply cosine of 5 pi over 3 times 2. Cosine of 5 pi over 3 is positive half again. 5 pi over 3 is right here. Almost 6 pi over 3. Positive half times 2 is 1. And I should have done it here. Also, I did twice times the cosine of pi over 3 of half is 1. Still positive, still the behavior. I just missed the constant multiple. So again, on this last interval, function is increasing. So now, just based on this array, I have a minimum at 0, a maximum at pi over 4, a minimum at 3 pi over 4, and a max at pi. So lastly, we just have to decide which one is which in the absolute or local. To find the absolute extremum, we'll plug them into the original. The original function, f of x, was twice the sine of 2x. So let's try the mins first. That happens at 0 and 3 pi over 4. Twice the sine of 2 times 0 is just 0, and twice the sine of 2 times 3 pi over 4 is twice the sine of 3 pi over 2, which is -2. So this minimum, 3 pi over 4, is an absolute minimum because it is smaller than 0, which is a relative minimum. Let's try the maxes. We had maximums at pi over 4 and pi. We'll test them in the original function. Twice the sine of 2 times pi over 4 is twice the sine of pi over 2, also known as 2. And twice the sine of 2 times pi is twice the sine of 2 pi, which is 0. So we have an absolute max at the big value, 2, and a relative max at the smaller one, pi. So let's go back up and label our stuff up here. There was a relative max at pi, an absolute maximum at pi over 4, an absolute minimum at 3 pi over 4, and a relative minimum at 0. Then we can fill out from this array, from step 2, well, we wrote it all right there in step 2, we can answer all these questions, increasing from 0 to pi over 4, and from 3 pi over 4 to pi, decreasing from pi over 4 to 3 pi over 4, an absolute maximum at x equals pi over 4, an absolute minimum at x equals 3 pi over 4, a relative maximum at x equals pi, and a relative minimum at x equals 0.